Assalamu alaikum dear students. In this video, we will discuss isomers of alkanes in detail. So, let's get started. First of all is the definition of isomers. These are the organic compounds having same molecular formula but different structural formula. To understand this definition, look at these two structures. The first structure consists of 4 carbon atoms that are joined together in the form of a long chain. But in the second structure, 3 carbon atoms are arranged in a chain, but their continuity is disturbed at the middle carbon due to the presence of carbon atom below it. So, second structure gives a different arrangement of carbon atoms than the arrangement shown in the first structure. But when we look for the carbon and hydrogen atoms in both the structures, both have same molecular formula, that is C4H10. So, these two structures refers to the isomers of each other as they have same molecular formula but different structural formula due to the different arrangement of carbon atoms in them. So, the question arises here that why do organic compounds form different structures, or why do organic compounds exhibit isomerism? The reason is it is due to the ability of carbon atoms to arrange themselves in long chains, rings and branched structures. This property of carbon atoms is known as catenation. So, this means that catenation is the property of the carbon atoms that enable them to arrange themselves in long chains, rings and branched structure. Now look at these three structures. In the first structure, carbon atoms are joined continuously in the form of a long chain without any disruption. Whereas in the second structure, carbon atoms links together in the form of a hexagonal ring. Whereas in the third structure, there is a main chain of carbon atoms, but there are carbon atoms present above and below the main chain. These type of structures are known as branched chain structures. Now, alkanes shows two types of isomers: straight chain isomers, which are also known as unbranched isomers, and the branched chain isomers. Unbranched isomers consist of straight chains of carbon atoms, whereas branched chain consist of carbon atoms in a main chain, and in addition to main chain, there are carbon atoms present above and below the main chain. This makes the branched structures. There are carbon atoms below and above the chain. These carbon atoms, or the group of atoms that are present below and above the chain, these group of atoms are known as branches. Now, what are branches in the branched chain isomers? Branches refers to the alkyl groups. Alkyl groups are known as branches. Now, how these alkyl groups are formed? They are formed by the removal of one hydrogen atom from an alkane. For example, the first member of the alkanes homologous series is methane. Its molecular formula is CH4. When it changes to alkyl group, it is known as methyl and its formula will be CH3. Now, carbon has an extension bond here, which means that it can be connected to the main chain and exist as branch there. Now, next member of the homologous series is ethane. Ethane will form ethyl group and its formula is C2H5. Propane is C3H8, so it will form propyl, C3H7. Butane is C4H10, so butyl will be C4H9. Now you will see that in alkyl groups there is one hydrogen atom less than that of the hydrogen atoms present in the respective alkane. So, as a general formula for alkanes is CnH2n plus 2, there is one hydrogen atom less in the alkyl groups, so its general formula will be CnH2n plus 1. Now, Let's start the isomerism in alkanes. The first member of the alkanes series is methane. Methane consists of only one carbon atom, so there is no other structure to represent the methane. So methane does not exhibit isomerism. Now in ethane, there are two carbon atoms present. Now these two carbon atoms, whether they are present, whether they are arranged horizontally or vertically or diagonally, the connectivity of the carbon atoms is the same. Their main chain is not disturbed. So ethane also does not exhibit isomerism. Now look at the propane. Propane has three carbon atoms. In the first structure, three carbon atoms are arranged horizontally. In the third structure, they are arranged vertically. The arrangement is not disturbed. All the three carbon atoms are arranged in a same manner. They are arranged in a continuous manner. But in the middle structure, two carbon atoms are present in the chain and the one carbon is present below it. However, this carbon atom can easily be twisted back to the main chain. So, this is also considered as a straight chain structure. This is not a branched structure. This means that all these three alkanes are straight chain structures. All these structures are same. So propane also does not show isomerism. Now look for the different possible structures for butane. In the first structure, all four carbon atoms are arranged in a continuous manner in a straight chain. However, in the second structure, three carbon atoms are present in a chain, but one carbon atom is present above it. However, this carbon atom can easily be twisted back to the main chain, so this is also considered as a straight chain structure. Similarly, in the third structure, three carbon atoms are present in a chain and one carbon atom is present below it. However, this carbon atom can easily be twisted back to the main chain. So this is also a straight chain structure. First, second and third structure are similar. Now look at the fourth structure. In fourth structure, two carbon atoms are arranged in a chain, but two carbon atoms are present above and below it. However, these two carbon atoms can easily be twisted back to the main chain. One carbon atom will go downward and the other carbon atom will move or twist it back upward. So this is also a straight chain structure. Next structure consists of carbon atoms. Three carbon atoms arrange themselves vertically, whereas one carbon atom is present left to the chain. However, this can be twisted back to the main chain. So the first five structures, they are similar to one another. All these structures are straight chain structures because the arrangement of carbon atoms in all these structures is same. Now look at the sixth structure. Structure number 6. There are three carbon atoms present in the main chain, but one carbon atom is connected to the middle carbon atom. It is connected to the middle carbon atom. So this gives a different arrangement of carbon atom because now this carbon atom cannot be twisted back to the main chain because when it tries to twist back, there are already group of atoms present with this carbon atom. So this is a different structure from the straight chain. This gives a different arrangement of carbon atoms. Now first five structures are similar. First five structures are straight chain structures. So we will name the straight chain butane as all the carbon atoms are normally attached in a straight chain, so its name will be N-butane. N stands for normal. So first five structures are all same, their name is N-butane. So now the sixth structure in which there is a different arrangement of carbon atoms. let me clean this structure a little bit. Now there are some rules for the compounds of the hydrocarbons that are arranged themselves in the form of a branched structure. So the first rule for naming the branched compounds is select the longest continuous chain of carbon atoms to get the main chain. So in this structure the main chain consists of 3 carbon atoms. This is the main chain of carbon atoms. The second rule is find the branch and name it. Now this is the branch that is present below the main chain, and what is its name? As it consists of only 1 carbon atom, so its name will be methyl. Okay, the next rule is start numbering the main chain. We have to number the main chain. Okay, we have to number the carbon atom in the main chain. The rule is start numbering the main chain from the side which is nearest to the branch. Okay, in this structure, whether we start numbering from the right side or from the left side, the branch is present at the middle carbon. So I will start numbering from here: 1, 2 and 3. There are 3 carbon atoms present in the main chain and a branch is present at the carbon number 2. Now finally write the name in the following sequence. Okay, what is the sequence for naming the branch chain compound? First is the position of the branch. Position of the branch means to which carbon atom is attached. Okay, the branch is attached to the carbon number 2 here, so we will write 2, then dash, hyphen is here, then is the name of the branch. The name of the branch is methyl, 2-methyl, and the name of the main chain. The main chain consists of all single carbon atoms, so this means that this is a 3 carbon alkane, so its name will be propane, without any spacing and without any capital letter. Its name will be 2-methyl propane. So there are 2 isomers of butane. N-butane means normal butane, which is a straight chain structure, and 2-methyl propane, which is a branched chain structure. Both of these structures, they have same molecular formula, but their structures are different due to different arrangement of carbon atoms. So these 2 compounds are the isomers of each other. Means butane has only 2 isomers. Next is, now we will draw the isomers of pentane. Okay, the easiest way to draw the isomer is to draw the chain of carbon atoms first and then complete the displayed structure by making bonds with the hydrogen atoms. So in pentane 5 carbon atoms are present. I will make a chain of 5 carbon atoms. Okay, the next possibility is that I will shorten the length of the carbon chain and take a branch at the second carbon. Always remember that at first and the last carbon of the main chain there is no branch. If there is some carbon atoms present above and below at the first and the last carbon atoms, they are considered as the part of the main chain. Always remember there is no branch at first and the last carbon atom of the main chain. These first and the last carbon atoms are known as terminal carbons. These are known as terminal carbons. At terminal carbons there are no branches. If the group of atoms are present, they are considered as the part of the main chain. Okay, this is the second possible structure for pentane. The third structure is that I will further shorten the chain length, and now there are 2 carbon atoms. I will draw 1 carbon atom above and 1 carbon atom below the middle carbon. There will be no branches at the terminal carbons. These are the terminal carbons that are marked with the stars. Okay, now I will complete their structures by making bonds with the hydrogen atoms. There must be 12 hydrogen atoms in each structure. There are 5 carbon atoms and 12 hydrogen atoms. In the first structure, as the carbon atoms are arranged in the continuous manner in the form of a long chain, so its name will be N-pentane, normal pentane. In the second structure, first I will make the hydrogen atoms to complete the displayed structure. Be careful while drawing the structure. Don't miss any hydrogen atom, otherwise you will lose a mark for it. Okay, now according to the rules for naming of the branched chain alkanes, so first of all we have to select the longest continuous chain of carbon atoms to find the main chain. Second rule is to find the branch and name it. This is the branch and it consists of 1 carbon atom, so it will be methyl. Now the third rule is start numbering the main chain from the side which is nearest to the branch. So if I start numbering from the left side, the branch come at carbon number 3. But if I start numbering from the right hand side, the branch come at carbon number 2. So which side is preferred? I will start numbering from the right hand side. Okay, now I will name the compound. Its name will be, first of all I write the position of the branch. Position means write down the number of carbon atoms to which branch is attached. So this is 2. Then dash, the name of the branch is methyl. Now how many carbon atoms are present in the main chain? There are 4 carbon atoms in the main chain, so this means it is a 4 carbon alkane. The main chain name is butane. 2-methyl butane is the name for the second isomer of pentane. Now look at the third structure. First I will complete its structure by making bonds with the hydrogen atoms. Okay, then I will name this structure according to the rule. First rule is select the longest continuous chain of carbon atom. This is the chain of 3 carbon atoms. Now second is find the branches and name them. Now there are 2 branches and both are attached to the same carbon atom. The name of both the branches is methyl, as both consist of 1 carbon atom. Okay, now start numbering from the side which is nearest to the branch. Either I start numbering from the right side or from the left. The branches are present at the middle carbon atom, so no matter where I start the numbering. So 1, 2 and 3. Now I will write down the name of this compound. This will be 2, 2, as 2 branches are present and both these branches are present on the same carbon atom, that is number 2. So I will write 2 times here. 2, 2 dash. Now there are 2 methyl, so I will use dimethyl, 2, 2 dimethyl, and the name of the main chain is 3 carbon atoms are present, so it will be propane. This will become 2, 2 dimethyl propane. So this is all about the isomers of pentane. So alkane with 5 carbon atoms consist of 3 isomers: N-pentane, normal pentane, 2-methyl butane, and last one is 2,2-dimethyl propane. These three are the isomers of each other because they have same molecular formula, that is C5H12, but they have different structural formula due to the different arrangement of carbon atoms in them. So this is all about the isomers of alkanes. I hope this all the things that are explained in this video will be helpful for you. Now practice the isomers of alkanes with the higher number of carbon atoms, and remember that as we go down the homologous series with the increase in the number of carbon atoms, the number of isomers also increases. So see you in the next video. Till then, Allah Hafiz.